Okay? So if the R function looks like this, then we've determined it algebraically. Good, check. And explain what it represents. Okay, any ideas? What does this represent? We're multiplying now the ticket prices, and we're multiplying that by the attendance. So what do you get when you multiply price per ticket times the number of people? Yeah, profit. Or little r, give you a little hint there for revenue, right? Yes, okay. So it represents the revenue. All right. So when you're dealing with systems like this with all these changing variables, a lot of times, and I mean when we're talking about big companies and they're trying to develop strategies for maximizing profit and stuff like that, it's not like a guess. It's not like, well, I think if we give away this stuff, more people will come and so we'll make more money. Let's try it and see. No, they try and model what's happening, take observation, and use the functions to predict so that this is what happens. It's not like a guessing game. That's why math is actually very important. It's behind the scenes, right? When owners of teams like this decide to do something, it generates something else, and it's planned. It's not like by accident. Okay? So that's just a little bit of a life connection there. Okay? So B, if we look at B, use the graph to determine whether the owner increases or decreases revenue from the ticket sales with the changes made to draw in new fans. Okay? So then in the revenue, all right, so whether the owner increases or decreases revenue from the ticket sales with the changes made to draw in new fans. So what we'll need to do, looks like, is we'll need to try and see what the revenue is as the game numbers increase. Okay, so in game 1, what do they make? In game 2, what do they make? And so on like that. Now we could do a chart. We could do a table of values. Or we could use our graphing calculator, couldn't we? So you guys have calculators? You do not. Okay, so take a minute to grab your calculator, and I'll fire mine up here, and we'll do this together. All right, so on your calculator, if you graph this function right here, again, just note that we have a parabola, okay? All right, it's degree 2. This leading coefficient is negative, so it should open downward. You may have to adjust your window. I have adjusted window settings there, so if you want to copy some of those, you can. But when we graph, we should have a parabola that opens downward, and it looks like this. And of course, this will be 80 right here, the y-intercept, because if you look at this graph, it's the only one that doesn't have a g value, right? So that means that it is the y-intercept 80. And so we have a maximum point right here. So remember, if this point is a maximum on the graph represents revenue. So this point right here is going to represent, the y value will be the maximum revenue, and the x value here will be the game number. Okay, and it might not be 1.0, it may be maybe 5.2. So somewhere on this continuum around game 5, between game 5 and game 6 is where they would reach their maximum. So that's obviously 5.2, what does that really mean? You might have to use whole numbers. The graph might be limited. Okay, so anyway, so if we go back to this, what does it say? Develop a model, explain what it means. Oh, use the graph to determine whether the owner increases or decreases revenue from the ticket sales. Well, he's going to increase revenue, right, for a little while, but if he keeps it up, that is, he randomly gives away noisemakers, okay, obviously it's going to lose its effect, according to this model. And so somewhere around here, he's going to make his most amount of money. But he does make money after he starts this. But he better change things here because he's going to start losing money now, right? Just keeps giving away noisemakers. Everyone gets annoyed with all the noisemakers, and they're sick of getting the same thing every game. They're going to tell all their friends that this sucks, and then nobody's going to come. He's going to lose money. So there's like a window, right? If you wanted to quickly find out, okay, what the maximum is, remember, second function trace, go to 4, look for maximum. The calculator will ask you, where's the left boundary here? So you go cursor over here, hit enter, right boundary, go to the other side of the maximum point. If there's anywhere over there, hit enter, enter again to get the calculator to guess. And So here we go. 98, and remember revenue. Um, Ticket sales were, well, we didn't really discuss kind of what the exact unit is, but anyways, the game number is what's important. Okay, so somewhere around game 30, he's going to make his maximum profit, but after that, it's going to start to drop off again. Okay, and then over here where the revenue is 0, right? That's where he makes nothing. Now he's still making money over here, but it's going down over time, right? So this is the that's the highlight right there. Okay, so both games period. So finally, question C says talks about this division, and so N is what? The number of noisemakers, and A is attendance. So N over A, what does that kind of represent? What does that mean? Right? What does that mean? It's number of noisemakers per the attendance. So it's basically it's the number of noisemakers per person, I guess, right? Or compared to the attendance. So it's how much you're giving away for how many people. So it's the number of free noisemakers divided by the number of fans. Okay, so noisemakers per fan. Per fan. And it's obviously going to be, a number that's A is, or N is hundreds of noisemakers. So hopefully that'll be a small number per fan, right? But that's going to be the function. And so for C, there's what you can put into your calculator, just the division of those two functions, N over A, and then you can graph that. Okay, so obviously our axes are all whacked out. If you get that and you're like, oh, obviously everything's changed now, X and Y, I don't know what to do. Just hit zoom 6 and see what happens. Okay, zoom 6 kind of gives you a standard window, and then you might see something. Okay, so it's what? Doesn't look quite right. Doesn't look like. I mean, you can see the graph generally if you have a zoom 6, unless your numbers are way off. So, okay, so let's take a peek at this. Make sure you do everything right. Remember, I guess we're talking about number of noisemakers per fan, but this function for noisemakers, N, is like hundreds of noisemakers. So hopefully, we're going to have, less than 100 noisemakers per fan. So it's going to be a pretty small number. So if we look at our window, the Y max, okay, is 10. Well, maybe that should be changed to something quite a bit smaller. What if we did 1, and then the minimum was -1? And again, we're talking about probably more than 10 games, right? So we might need to increase the X max to maybe, 40 games. Let me try that. The X min does not need to be -10. Let's put that at 0 or -1. So if we change that, what happens? Oh, there we go. Okay. That looks a little bit better, right? Okay, so obviously we have lots of noisemakers, comparable, per fan at the beginning, right? And then, okay, more fans will come, right? Less noisemakers will be distributed, and so the number of noisemakers per fan gradually goes down, okay? So the question says, what's the chance of receiving a free noisemaker for a fan attending game 4? Well, let's see. If we calculate a value of x equals 4, that's game 4, what do we get? 0.2045. So if that's 100 noisemakers per fan, that's going to be 0.204 times 100 is 20 noisemakers per fan. So the chance of getting a noisemaker, okay, is pretty good. 20 out of 100, or a percentage of 20. What did I say? 20 noisemakers per fan? Not really. 20. No. This function is noisemakers per attendance. So it's not 20 per fan, but this would represent a 20% chance. Yeah. So you have a chance of 0.2. Okay. So 0.2 noisemakers per fan. That makes more sense, I guess. Yeah. 0.2. So you have a 20% chance. game 4. Make sense?